I want to start today by talking about friction. Usually when we talk about friction in, business or operations, it's the enemy.
Right, you want things to be seamless.
Exactly. Frictionless transactions, frictionless communication. But today we're looking at a stack of documents specifically focusing on these industrial safety protocols, like the ones used in the ABM project, that argue the exact opposite.
They argue that you need friction.
Yeah, that sometimes you have to deliberately introduce friction to save lives.
That's a really interesting way to frame it. I mean, we're all conditioned to think that speed equals efficiency.
Of course.
But in the world of high-risk industry, speed is. It's often just a precursor to disaster.
Exactly. So we're diving deep into the work permit system, or the permit to work. And I have to be honest, when I first saw the topic, my eyes kind of glazed over.
Huh, I can imagine. It sounds incredibly dry.
It sounds like the ultimate bureaucratic nightmare, right? Like
Yeah, right.
forms and triplicate just to change a light bulb. But as I went through the source material, I realized this isn't about red tape. It's about creating a forced pause.
Forced pause is the perfect term for it.
Mm.
If you look at the ABM project documents, or really any major industrial standard,
Yeah.
the work permit system isn't just a checklist.
No.
It is a formal, legal, and operational agreement. It's kind of like a contract for the day.
So let's set the scene for you listening. We aren't talking about an office environment here.
Not at all.
We're talking about that ABM project, context-heavy construction, industrial maintenance, refineries, power plants, places where if you make a mistake, you don't just delete a file.
No, you might cause an explosion. The stakes
That's
are,
awesome.
they're existential. So the mission of this deep dive is to unpack how we authorize and control what the industry calls non-routine activities.
And that distinction is key, right? Non-routine.
It is. That's
Yeah.
where we should start.
Yeah, let's drill into that because I imagine there are people on these sites doing the exact same thing every single day. If I'm a machine operator, do I need a permit every morning just to turn my machine on?
Generally, no. That's a routine operation.
Okay.
The risks are known, the controls are built into the machine, and you are trained to run it. It's muscle memory.
Okay.
The work permit system kicks in when you break that routine, when you need to open a pipe that is usually closed, or when you need to weld on a structure that is usually cold, when you're doing maintenance.
So it's for when the variables change.
Exactly. When you introduce new variables, you introduce new chaos. The permit system is designed to identify that chaos before you even start working. It's proactive.
Right, proactive hazard identification. The sources mention a few key components that make this whole system work. It's not just a verbal, okay, go ahead.
No, it has to be written. And critically, it has to be authorized by a qualified authority.
That's a crucial point.
It is. It's not your buddy saying you can do the work. It is a specific person, a site supervisor or a safety manager, who has to put their signature on that document.
I always think about that signature as a kind of transfer of anxiety.
Oh, that's good.
When a supervisor signs that permit, they are legally and ethically taking ownership of the safety of that entire task.
That is exactly what it is. They're certifying that they've looked at the plan and basically deemed it survivable.
Another thing that stood out in the notes is the concept of validity. These permits are on a really tight timer.
A very tight timer.
They aren't valid for a week or a month. It says usually just for one shift or maybe one day.
And this is where that friction we talked about comes in. It would be so much more efficient to just issue a blanket permit for the whole week, right?
Sure, hey, you're welding all week, here's your pass.
But the system forbids that. And the reason is because the site changes.
The environment is dynamic.
Precisely. A walkway that was clear on Monday might be blocked by a crane on Tuesday. The wind might have picked up. A different crew might be working just overhead.
So the permit is a snapshot.
It's a snapshot of safety for a specific window of time. If you step outside that window, even by a few hours, the data in the permit is stale. It's just not valid anymore.
That makes so much sense. It prevents you from relying on yesterday's reality. And the final piece is closure. You can't just finish the job and go home.
No, you have to formally close the permit. It's the bookend to the whole process. You open the risk, now you have to close the risk.
You have to certify you didn't leave a wrench in the gears or a smoldering fire.
Exactly.
Okay, so that's the mechanism. But let's get into the actual hazards. The sources list what they call the Big Five, the types of permits. And I think this is where you really see why the system is so robust. It's not for everything.
No, it's for the heavy hitters. These are the 5 categories that statistically kill or injure the most people in industrial settings.
And number 1 is hot work. Now, this sounds straightforward: welding, cutting, grinding, fire. But the source material gets into some really interesting detail here. It's not just about the open flame, is it?
No, and this is where expertise really comes in.
Hmm.
Hot work isn't just about the spark you can see. It's about heat conduction.
Ah.
So if you are welding on a steel beam, that heat travels. It can travel through the beam, through a wall, and ignite insulation or a cable tray in the next room over.
That's terrifying. So you could be welding completely safely in one room and literally start a fire in another.
Exactly right.
Yep.
And that's why the permit requires you to inspect the surrounding area, not just the weld point. It forces you to think about where the heat is going to go.
Okay, the second one is confined space entry. This one always gives me the creeps. Tanks, pits, tunnels.
Yep.
The source notes mention the danger isn't just getting stuck, it's the atmosphere.
A confined space is so deceptive. A tank looks empty, it looks safe. But if it was previously holding, say, nitrogen, or if there's a slow gas leak, the air inside might not support life.
And you can't smell it.
You can't smell oxygen deficiency, you just pass out.
So the permit acts as a physical barrier to entry.
Literally.
Yeah.
You cannot break the plane of that entry without a permit that proves the air has been tested with a gas detector. It stops you from walking into an invisible trap.
Then we have electrical work. This seems tied to lockout-tagout, which we've discussed before.
Yes, specifically on live systems or complex grids. It prevents that classic nightmare scenario where someone is working on a circuit and another person in a control room 2 miles away flips a switch because they didn't know work was happening.
The permit bridges that communication gap.
That's all it is.
Height work is the fourth one. Scaffolding, roofs. I mean, gravity is the one constant hazard we can never turn off.
And people get so complacent with height. Oh,
Yeah.
it's just for a minute, they say.
Right.
The permit forces the check. Is the harness inspected? Is the anchor point valid? Is the weather safe? You do not want to be on a scaffold in high winds.
And finally, excavation. Digging. This one surprised me a bit because digging seems so primitive. But the risks are massive.
They are. You've got two main risks. One is hitting something like a high voltage line or a gas main.
Which is bad.
Very bad. But the other is a cave-in. Soil is incredibly heavy. A cubic yard of dirt can weigh as much as a small car. If a trench collapses on you, you don't dig your way out. The permit ensures you have shoring and that you've mapped all the utilities.
So those are the big five. And what I'm hearing is that the permit system is essentially a tool to force a reality check against, well, physics.
That's a beautiful way to put it. It forces a pause to check reality against physics before you put a human body in the middle of it.
Now, I want to walk through the actual life cycle of a permit. The source material outlines the SOP, the standard operating procedure. And I want to play devil's advocate here a bit because this sounds like a lot of steps.
It is.
So let's say I'm a contractor on the ABM project. I need to fix a pipe. I'm behind schedule. My boss is yelling at me. Walk me through what I actually have to do.
Okay. Step one is initiation and request. You can't just grab your toolbox. You have to sit down and fill out the request. But here's the key part. You also have to submit a preliminary risk assessment, often called a JHA or a job hazard analysis.
This is the part that feels like paperwork to people. Why do I have to write down that I'm using a wrench?
Because the act of writing it down forces you to simulate the job in your head. You have to think, okay, I will be standing on this ladder holding this heavy wrench over this moving conveyor belt.
And just by writing it.
By writing it, you might realize, wait a minute, if I drop the wrench, it goes right into the belt. It forces a mental rehearsal.
Okay, so I've done my homework. I've submitted the request. Step 2 is site evaluation.
And this is the make or break moment. In a lazy system, the safety officer just signs the form at their desk.
Right.
In a robust system, like the one described for the ABM project, the safety officer must go to the site. They have to put eyes on the actual problem.
What are they looking for that I missed? I mean, I know how to fix pipes.
They're looking for the context you might be ignoring. You're focused on the pipe. The safety officer is looking at the entire environment. Maybe 10 feet away, another crew is painting with flammable solvents. You didn't notice because you're focused on your job, but the safety officer sees the conflict. Your welding sparks plus their fumes equals an explosion.
So this is where the power of no comes in.
Absolutely. The safety officer is the gatekeeper. If the risks are too high or if the controls, that's the safety gear and protocols, aren't sufficient, they deny the permit. They are the only people on site with the authority to say, stop production to save a life.
That has to be a tough position to be in socially. I mean, everyone just wants to get the job done.
It is. It takes a lot of backbone. But the permit gives them the authority. It depersonalizes the no. It's not, I don't like you. It's the permit conditions just aren't met.
So let's say I get approved. Step 3 is approval, where the document is signed by all the stakeholders. Step 4 is execution. Now, I'm ready to work, but the notes mention a briefing here. Is this just another meeting?
This is often called the toolbox talk. And yes, it can be just another meeting if it's done poorly, but the purpose is critical. You, the person who filled out the form, you know the risks. But do the three people helping you know them?
Good point.
The briefing ensures that the knowledge isn't trapped in one person's head. Everyone needs to know. If the alarm sounds, we go that way.
And during the execution phase, there's this concept of the stop work rule.
This is vital. The permit is valid for specific conditions. If those conditions change, the permit is void. So let's say you're working at height and a thunderstorm suddenly rolls in.
The permit is useless.
Or you smell gas. The permit doesn't protect you from lightning or an explosion. The work must stop. Period.
I feel like that's the hardest thing in practice, to be the person who says, hey, I know we're almost done, but I smell something weird, so we're stopping.
It is incredibly hard. It goes against our basic instinct to finish the task. That's why the system has to explicitly empower every single worker, from the apprentice to the manager, to call a stop work without any fear of punishment.
Once the job is done, we have step 5, completion and closure. This isn't just clocking out.
No. You have to inspect the site for what they call residual hazards. Did you leave a piece of hot metal that could smolder and catch fire 2 hours from now? Did you leave a tripping hazard? You have to leave the site as safe as you found it.
And finally, step 6 is the audit. This is the data loop.
Right. Records are kept, usually for 1 to 2 years. And this isn't just for legal cover, it's for learning. If you look back at the permits and see that every time we do hot work in Zone B, we have a near miss.
Then maybe there is something wrong with Zone B.
Exactly. It turns the paperwork into data for actual improvement.
I want to pivot now to what I think is the most fragile part of this whole system, the human factor.
Yep.
We can design the perfect form, but if people just pencil whip it, check the boxes without actually looking, it's completely useless.
Pencil whipping is the enemy of safety. It just turns the entire system into theater.
So how does the ABM project material suggest we handle this? How do we keep people engaged?
Well, it starts with induction. When a new hire arrives, they don't just get a hard hat. They go through specific training modules. They are taught why the permit system exists.
So you build the culture from day one.
You have to indoctrinate them into the culture of safety before they even step on the field. They're shown the emergency plans, everything.
But training wears off. People get complacent.
Of course they do, which is why the source emphasizes ongoing training and refresher courses. You might do a monthly deep dive on a specific topic. Or, if you're a supervisor who issues permits, you get advanced training on hazard recognition. You have to keep the knowledge fresh.
There was one specific role mentioned in the context of hot work that I found really fascinating, the fire watch.
Yes, this is a great example of a specialized human control.
Describe this job because to an outsider it sounds kind of boring.
On the surface, yes. If you are doing high-risk welding, the permit might require a dedicated fire watch. This is a person whose only job is to stand there with a fire extinguisher and watch.
They don't do anything else.
They don't help weld. They don't hand you tools. They don't check their phone. They just watch for sparks and smoke.
That requires a level of discipline that's actually really hard to maintain. To just do nothing but watch.
It's incredibly difficult. It's boredom, punctuated by potential terror. But they are the sniper of safety. They're looking for the threat that the welder can't see because the welder's, looking at the arc.
There's another human element here that is a huge vulnerability: contractors. If I'm the plant manager, I know my rules. But if I hire an outside plumbing crew, they might be used to a totally different standard.
Contractors are so often the weak link in safety systems. Not because they're bad workers, but because they're culturally disconnected from your site.
That was the rule.
The source material is very clear. If contractors are on your site, they follow your permit system. End of story.
My house, my rules.
Exactly. You have to integrate them into the pre-work meetings. You can't just assume they know that Protocol A applies here. You have to treat them as if they are your own employees for the duration of that task.
And speaking of rules, the source touches on regional compliance. It mentions aligning with local laws, referencing things like the Factories Act in India or OSHA guidelines. Why does the geography matter? I mean, physics is the same in India as it is in the US.
Physics is the same, but liability and law are very different. The work permit system is often a legal requirement. In the context of the source mentioning Uttar Pradesh or Agra, There are specific local statutes about how long you keep records, what forms need to be filed for an excavation, and who is criminally liable if an accident happens.
So the system has to be a bit of a chameleon.
It has to be adaptable. It has to satisfy the company's internal global standard. We want everyone to be safe. And the local government standard, which might be, you must fill out Form 12B.
So you ignore the local context at your peril.
You ignore it, you are opening the company up to massive legal risk. It connects that global best practice to the local reality.
It ensures that the safety net is tight no matter where the site is located.
It does.
So we've covered a lot of ground here. We've gone from I hate paperwork to understanding that this stack of paper is actually a sophisticated algorithm for survival.
That's a great way to think about it.
We've looked at the big 5 hazards, the step-by-step SOP, and the training required to actually make it stick.
If we zoom out, the work permit system is really just a loop. Assess, authorize, execute, close. It's a continuous cycle designed to catch human error before it becomes a statistic.
And I think that's the key. It catches human error. We're fallible. We get tired. We get distracted.
Right, and in a low-risk environment, if you get distracted, you make a typo. In a high-risk environment, you lose a finger, or worse. The so what here, for you listening, is that the permit to work is a tool to force mindfulness.
Institutionalized mindfulness. I like that.
It breaks the autopilot. We all want to be efficient. We all want to just get into the flow. But when the environment is trying to kill you, autopilot is your enemy. This system forces you to stop, look at the world as it actually is, not as you assume it is, and then proceed with intention.
It bridges the gap between getting it done and getting home safe.
Exactly.
Yeah.
And that is the only metric that really matters at the end of the shift.
I want to leave everyone with a thought to chew on today. We often view barriers to work, like filling out forms, waiting for a signature, or doing a walkthrough, as inefficiencies. We stand there tapping our foot thinking, this is slowing me down, I'm wasting money. But in the context of the work permit system, I want you to ask yourself this. Is that inefficiency of stopping to sign a paper actually the most productive thing you do all day?
Oof.
Because ultimately that signature guarantees there's a tomorrow to come back to work.
That is a very sobering thought. Sometimes slowing down is the only way to keep going.
Couldn't agree more. Stay safe out there, stay curious, and maybe look at that next form you have to sign with a little more respect. Thanks for listening to The Deep Dive.